أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Dear students, open your books and come on page 50. Previously, we were talking about the magnetic field, space or region around a magnet where its force of attraction or repulsion experienced there. That force of attraction or repulsion called magnetic field. Then we were talking about the suspended bar. If a bar is suspended, then it will point roughly north-south. The unlike poles of the magnet will always attract each other, whereas the like pole will always repulse each other. This is the review of your previous lecture. I hope so that you all know about that lecture. Today, inshallah, we will discuss the theory of magnetism, and at the end of this lesson, you people will be able to show how magnets and electromagnets can be used in a number of devices and to distinguish between the magnetic and non-magnetic materials. Now, towards our today's main topic, that is a theory of magnetism. Theory of magnetism gives us idea about experiments. That experiment shows the properties of magnets and magnetic materials. We all know that that experiments we perform give us about the idea of magnets and magnetic materials, but those experiments do not explain what is happening. So a theory is needed there to explain the effects of magnetism and to help us use those experiments. So we must be connect those experiments with a theory that will explain those experiments. Look at here in this figure. This is a bar magnet. This is so-called a bar magnet. S pole and N pole of the magnet. If you break this magnet into pieces, what will happen that each and every piece will behave like a tiny magnet. When a magnet is broken, all the pieces are complete magnets. You can see here, this is the complete magnet. If you make this magnet into pieces, or if you broken this magnet into pieces, what will happen that each and every piece or the broken piece of this magnet will behave like a complete magnet. Magnetized and demagnetized domains. Basically, domains are the atoms that were present in a magnetic material. Before applying the magnetic field or the external magnetic field, what will happen that those domains are the atoms that were present in a magnetic material that will be aligned in a random direction. And random direction means that there will be either in upward direction, that will be in downward direction, leftward, rightward, or any other direction. But if you apply the magnetic field on those atoms, what will happen? That those atoms will be aligned in a specific direction. You can see in this figure that all the atoms of this material will be aligned in a specific direction after applying the external magnetic field. So, in not magnetized form of a material, in a material that is not magnetized, the magnetic domains point in random direction. And if a magnetized material, all or most of the magnetic domains are arranged in the same direction. You can see here in this figure that all the atoms are arranged in a specific direction. Come towards this diagram, you can see here that this is the structure of a magnetic material. You can see that the domains are aligned in a specific, not in a specific direction, but they will be aligned in random direction, or randomly they will be aligned. After applying the external magnetic field, this B represents the external magnetic field, that if you apply that magnetic field on a material, all the atoms or all the domains of the material will be aligned in specific direction. And you can see here, this is a magnetized material. After that, you can say that a magnetized material. Now, supporting the theory, A magnetized steel rod has N pole at one end and S pole at the other end. If the rod is snapped into two, or if you can break the rod into two pieces, each piece has its own N and S pole that will become a tiny magnet, and the magnet have both the poles, that is so-called N pole and S pole. Breaking into smaller and smaller pieces produces smaller and smaller complete magnets. Okay, you can see here in these figures, this is the direction of the atom or the domains before applying the magnetic external magnetic field. So magnetic materials can be thought of as containing tiny molecular magnets. You can see here these are the tiny molecular magnets. Inside a material like iron, the molecular magnets can line up in groups called domains. Diagram shows how the domains are randomly arranged in a piece of unmagnetized rod. You can see here in this figure that these atoms are or these domains are arranged randomly in either direction that will be pointed. Okay, but after applying the external magnetic field, because these domains are quite sensitive for the external magnetic field, so domains are sensitive in the magnetic field. So if magnet is placed nearby, or if you apply the external magnetic field, its magnetic field causes the domain to line up in a orderly way. You can see here that these domain will be aligned in this order. You can see now they have a specific direction. Okay, so this is so-called magnetic material. This makes the iron into a magnet. Okay, and the iron will become a magnet. It becomes magnetized. Okay, so you can see here this is the iron bar. Before applying the external magnetic field, you can see here that all the atoms are aligned in random direction. Okay, you can see here that each and every atom have its own direction. After applying the external magnetic field, or if you bring the magnet uh, beside this piece, the atoms will be aligned in a specific direction. You can see that all the domains are aligned in a specific direction. So domain in unmagnetized iron top line in an order way when a magnet is nearby bottom. Ahmed Shahid, you have a question?
सर मैं दूसरी डिवाइस से अपना कनेक्ट करने लगा हूँ.
What?
सर वो कह रहे वो दूसरी डिवाइस से कनेक्ट करने वाला है.
Okay, fine. So domain in unmagnetized iron, you can see here, this is an unmagnetized iron piece, okay? And this is the orderly way when the magnet is nearby, okay? So the magnet is nearby to this piece and this is in order. Okay, using the theory, it is easy to magnetize a piece of iron by stroking it repeatedly with a magnet. How to make a magnet? Okay, how an iron piece to become a magnet? So what should you do there? You can stroking the piece of magnet on iron piece repeatedly, and after that the domains present there in the piece of iron will be aligned and they will be having like a magnet. So a permanent magnet can be demagnetized by heating it up and then quickly cooling it down. Cold water. The diagram shows what happens to the domain when it is. How to make a magnet unmagnetized. Okay, how to make a magnet demagnetize or unmagnetize. So we can say or we can do it that first of all we will heat that piece and then suddenly we will cool down in cold water so that will become demagnetized. These are the ways how to make the magnet unmagnetized by hammering. Okay, you can see here that you can hammer the piece of the magnet repeatedly, and after that you will observe that the behavior or uh, the magnetic quality of the magnet will be quite lost. Or if you drop it repeatedly, okay, on a hard floor, you can drop it repeatedly, then it will become demagnetized. And the third way is to heat it and suddenly cool it. So the magnetic property, the magnet will lose its magnetic property and it will become demagnetized. You can see here in this figure, this is the rod. Okay, you can see this is a rod, a magnetic field, a magnetic bar. If you hold this magnet, then the molecule will be unaligned. Okay, you can see here in this figure, and then you should suddenly drop it into a cold water. What will happen is that the molecule will be unaligned there, and it loses its magnetic property. So hitting a magnet with a hammer or simply dropping it onto a hard floor will demagnetize a permanent. Summary of today's lecture is magnetic field at the space or region around a magnet where its force of attraction or repulsion can be experienced. We can say that a magnetic field, and when a magnet is broken, all the pieces are complete magnets. The inflow of the magnet attracts the spole of the magnet as it moves across the iron, and energy from heating causes molecules to move fast. Okay, so let me repeat the lecture in Urdu.